Okay guys, 19.4, we are solving systems using tables. So we are looking at Amma and Joan, who plan to hike on the Riverside Trail from their neighborhood to the lake. But Joan has to work at the library in the morning, so she texts Amma that she will start later and catch up on her bicycle. So Joan leaves 4 hours after Amma. Amma hikes at 3 miles per hour and Joan cycles at 7 miles per hour. When and where will Joan catch up with Amma? Okay, so we're gonna go through and just pull some information out and fill out Amma and Joan's table. So if I'm looking at Amma, I know that Amma hikes at 3 miles per hour, so I can fill that in. And if you're not sure after how many hours Amma starts, you can look at her table and it says right here, 0 hours. Okay, let's pull some information about Joan. Joan cycles at 7 miles per hour and she leaves 4 hours after Amma. So she starts 4 hours after Amma and she cycles at 7 miles per hour. Okay, we're going to use the miles per hour, which is actually the slope of our equations here, and we're going to fill in the rest of the table. So if we look at Amma's table, you can see that we have this pattern of +3, and that comes from the 3 miles per hour. And we're just going to extend that pattern and fill in the blanks. So 12, 15, 18, and 21. I'm just getting by adding 3 between each term. Okay, we're going to do the similar thing with Joan, but Joan is traveling at 7 miles an hour, so we're going to be adding 7 all the way down this table. Okay, so 7, 14, 21, and 28. Okay, all right. Let's take a look at these questions. So at what time are Amma and Joan at the same distance down the Riverside Trail? So we are looking in these tables and we're looking for where both tables show the same distance at the same time, because that's where they're going to end up meeting. And if we look at 7 hours after Amma's start, both girls are at 21 miles down the trail. So at what time? We can answer at 7 hours. The next question is asking us what their distance is when they meet. So the distance refers to the y value, which is 21 miles. So they're 21 miles down the trail. Okay. How can you identify the solution by looking at the two tables? Well, we know that they're at the same distance at the same time. So let's just write that down. They are at the same distance at the same time. At the same time. Okay, why are the first 4 rows in the distance down the trail column of Joan's table grayed out? I apologize for the toddler that just walked in. Why are the first 4 rows in the distance down the trail column grayed out? Well, if we go back to our problem and we look at 0, 1, 2, 3 hours after Amma's start, Joan hasn't started, so that's why these are blocked out. So because Joan starts 4 hours after Amma. Okay. All right, let's take a look at the painting problem. Okay, so same type of situation. We're going to go through and fill in these sentences, look at the table. So we're still solving using a table. So your uncle needs the walls of his storage room painted. He is a smart shopper, so he asks his friends for recommendations. of painters. He finds 2 he thinks will do a good job, Evelyn and Rico. So Evelyn charges an initial fee of $80 for any job and $1.20 per square foot. Rico charges no initial fee, but charges $1.90 per square foot. Which painter's deal is better for your uncle? Okay, so let's go through and fill out these sentences that are started for us. So Evelyn charges an initial fee of $80 and $1.20 per square foot. Okay, so remember, our initial fee is our y-intercept, and our rate is $1.20, or our slope. Okay, Rico charges no initial fee, but $1.90 per square foot. All right, so we have to write a system or equations for both of these. So again, your initial fee or your starting value is your y-intercept, and then your rate per square foot, that's your slope. So that's going to help us write these 2 rules here. So we know that Evelyn has $80 flat fee and then $1.20 slope. So we're going to use C for cost, which is our y value, and A for the area, which is our x value. So C is equal to the slope times the area plus the y-intercept. And we're going to do the same thing for Rico. The cost is equal to the rate or the slope times the area plus the y-intercept, which in this case is 0. You do not have to write the 0 there unless you want to. Okay. All right, I am going to fill in this table using this rule for Evelyn. So really all I'm doing is I'm going to take the x values and plug them in for the area. And I'm going to do that all the way down. And you can use Desmos for this, or you can use your calculator on your phone, either way. So I'm not going to write this all out, but I'm going to continue that process all the way down and just changing the area to 0, 20, 40, 60, 80, and so on. And when I do that, I'm going to get 80, 104, 128, 152, 176, 200, and 224, 248, and 272. Okay, I'm going to do the same thing with Rico. I'm going to use his rule, which is 1.9 times the area. And I'm going to do the same thing over here, just substituting in the new area each time. And that's going to give me 0, 38, 76, 114, 156. Oh, I'm sorry, 152, not 156. 190, 228, 266, and 304. Okay, and we're going to use these tables to answer the follow-up questions. So use your equations and tables to determine for what area would Evelyn's deal be better, for what wall area would Rico's deal be better, and when would the cost be equal. Okay, so we're strictly using the tables here. So if I look for 0 square feet, I can see that Evelyn is 80 and Rico charges 0. So Evelyn is more expensive. For 20 square feet, Evelyn is still more expensive. For 40, 128 is still more expensive than 76. 152 is still more expensive than the 114. 176 is still more expensive than 152. And 200 is still more expensive than 190. But look at what happens next when you get to 120 square feet. Evelyn is now less expensive than Rico, and at 140 square feet as well, and at 160 square feet as well. And this is going to continue. So for this little, I'm gonna kind of give us a little block here. Right when this changes from Evelyn being more expensive to being cheaper, okay, that's where our solution occurs. So if we're going to answer when is Evelyn's deal better, well, Evelyn is cheaper after 120. So Evelyn is the better deal for 120 square feet and higher. Okay. And if we look back at our table, anything above in the table, above this little squiggly line, so anything less than, or 100 or less, is where Rico is cheaper. So Rico is cheaper above this little squiggly line. Okay, so Rico is the better deal at 100 square feet and lower. Okay. Now, where do they meet? That's also a question that you're being asked. For what would they be equal? Based solely on the table, we can say that somewhere between 100 and 120 square feet they're equal. And that's really all we can tell from the table. So somewhere between 100 and 120 square feet. Now, if I was asking you to use a graph, or I was asking you to solve this algebraically, you could come up with a more precise answer, but we are just looking at the table. Okay, so if we graph the painter's total cost in dollars as a function of the area in square feet, so meaning if we graphed these two lines, if we graphed Evelyn and Rico's lines, what would the graphs look like? Okay, well, we know that they're both linear functions, so they would look like two lines. And we also know that they do intersect by looking at our table, because Rico was cheaper and then Evelyn became cheaper. So we know that they intersect, so two lines that intersect. Between x equals 100 and x equals 120. Okay, that is all that we can say based on the table that we have been given. Okay, stay tuned for the second part of the video.